Step 27, we're going to talk about inverses of various relations and functions. An inverse occurs by exchanging the x and y coordinates of each ordered pair in a relation. So if you start with the ordered pair 5, 3, then 3, 5 would be the ordered pair of the inverse relation. You literally just switch the x's and the y's to make an inverse. It's quite simple. Let's practice on example 1a. In order to find the inverse of 1a, we would get 8, negative 6, 11, negative 15, 3, 9, 6, 0. Switching the x and y's here, we would end up with 5, negative 10, 11, negative 4, 12, negative 3, and finally 15, 0. But what happens when we have a graph? Well, that just means that every single point on this line, and we know how many points are on this line, it's an infinite number of points. I'm only marking the points with integer coordinates right now. But there are many, many, many points in between each of these integer coordinate points. And we're just going to do the inverse of each one. So this is the point 1, 2. So the new point would be 2, 1, which is right here on the green line. And if the point is 4, 3, the new point would be 3, 4. Actually, I had it right the first time. Got it mixed up. 3, 4 is the name of that point. So it would respectfully map to 4, 3, and so on. One thing I want to point out when you're looking at graphs, if you were to fold this graph on an imaginary dotted line so that the original blue line lines up on top of the new inverse green line, you would fold it over this red dotted line. The equation of this red dotted line is the equation y equals, we're going up 1 over 1, so y equals 1x plus 0 because it goes through the origin. So we don't even really need the plus 0. This is the line y equals x. All lines that are reflected across the equation y equals x will result in their inverse. So for example, if I take and draw in the inverse line, which is y equals x, and imagine taking this graph and folding it in half so that each point reflects over the graph, I would end up with a line that goes through this point. I would end up with a point, let's see, this is the point 5, negative 1. I'd have negative 1, 5 right here. This is the point negative 1, 1. So 1, negative 1. Actually, you know what? I think I miscounted. My apologies. This is the point 5, negative 1. So I'd go negative 1, 1, 2, 3, 4, 5, right here. Let's find some other points. This point right here on the blue line, that's what I was calling negative 1, 1. So now I go 1 and negative 1. It would be right here. I actually need these points on the blue line. And after I get enough of them, then I could go back and grab my ruler. Grab the ruler feature. Turn that on. Make my screen bigger again. And I could connect these green points once I have more than 2. Or at least 2, I should say. I'm going to push my ruler off to the side. I have graphed the inverse. Let's try to do the same thing here. Again, if we're taking and reflecting each point over this red dotted line, which is the line y equals x, this point would remain where it is. This point is 5, 3. Now we want the point 3, 5. This point is negative 1, 1. We want 1, negative 1. And so on. You start to notice the pattern as we reflect over that line. And then we can draw it in. Push the ruler out of the way, and we've graphed the inverse. Often we're just going to have an equation, not a graph, not ordered pairs, and we're still going to want to find the inverse. Well, by following these simple 4 steps, we can do just that. But rather than talk you through each of these steps, I'd rather just show you an example of them. So for instance, if we want to find the inverse of this function, we could graph it, and we could reflect it over the line, y equals x, but that involves graphing. We want to do this without graphing. So the first thing we're going to do is write the original equation. F of x equals 4x minus 8. Next, we're going to replace the f of x, the formal function notation, with a simple y. Y equals 4x minus 8. Now, just like we did before with the ordered pairs, we're going to switch the x and y values. So now we have x equals 4y minus 8. At this point, we just need to solve for the new y. In fact, we could add that to our line of instructions here. Solve for y. To do that, we're going to add 8 to each side. On the right side, the 8's cancel out, and I'm left with 4y. On the left, x and 8 are not like, so they just stand next to one another. Then I divide each side by 4, because again, my goal is to get y by itself. And finally, we replace the y with the formal notation f inverse of x, which equals x plus 8 over 4. So the inverse of f of x equals 4x minus 8 is x plus 8 over 4. Or you could split it apart if you want. Remember, when we have 2 terms over 1 term, you can split them apart. X over 4, 8 over 4 is how we're getting 1/4 and 2. If you would like to simplify, you don't have to though. All right, let's try another one. Here, we're going to write the original equation. F of x equals negative half x plus 11. We're going to replace the formal function notation on the left with just a y value. And then we're going to interchange the x with the y. So now we have x equals negative 1/2 y plus 11. Now we have to solve for our new y and get him all by himself by subtracting 11 from both sides. And finally, multiplying each side by negative 2, because that's the same thing as dividing by a negative half. On the right side, these cancel. And on the left, after we distribute, we have negative 2x plus 22, which equals y. Finally, we just replace it. I usually put my y on the left side. So f inverse of x equals negative 2x plus 22. Pause the video and try 3a and 3b on your own, and then check your answer, please. Hopefully you got these same answers, that f inverse of x equals 3x minus 21 for the second one, For the first one, there's two different answer choices depending upon whether or not you split the fraction into two fractions. Either answer would be acceptable.